Okay, going on to section 10.3. I think some of this work I can do on this page as well. We get into 10.3, you guys, and now we're in a position we don't have necessarily always these central angles at the center. Sometimes we're dealing with these inscribed angles, like out here. There's a big difference in how we handle these things. One of the things that I know holds true from section 10.3 is if I've got these chords right here, A, B, and ED the same, that means these central angles are the same. This question wants the measure of arc AB, so arc AB is going to be 61 degrees for that one. I've got arc AB over here. Same situation going on, and I don't know this theorem number. I would suggest you go looking, but these two chords are the same, or this chord is bisected. If this angle is 65 degrees, out here, this angle is going to be 65 degrees as well, those arc lengths. Now, if you notice there's a 90-degree angle for sure, but that's not a central angle. And so that's why those arcs aren't 90 degrees, because that angle isn't in the center. The only time that they're equal to the arc is when they're in, the angle is coming from the center. It's a central angle. 91 degrees is going to match over here for our AB because of the congruent relationship. Boy, and again, I want to take just a second and look in my notes. What theorem is this? And then number 22 is definitely a lengthy problem. We're going to stop off for that, but I just want to look at 10.3. What theorems are we talking about here? This guy here is theorem 10.6. Number 21 is theorem 10.6. No, it's not. It's 10, this one's 10.7. 20 is theorem 10.7. Nope, I'm a liar. This is not theorem 10.6, it's 10.9. Number 21 is 10.9. 20 is 10.7. 19 is, what is 19? Boy, I don't know. 19, what would we do with 19? Central angle. You know what? I think 19 is just going back to congruent central angles. Oh, this is actually from section 10.2. This is theorem 10.4. I knew I could find it. Theorem 10.4 for that one. Now, with this problem 22, boy, is this one tricky. There's a lot going on in here, and in the end, they want a radius. And the thing that I thought was funny about this problem is I don't even know if you guys noticed, but there's not one single radius. Well, I'm lying, there is. There's not one radius that's hanging out by itself. Like I've got Q out here to the edge of the circle. I got Q to L here. But the way that I want you guys to think about this right now is let's draw in, let me grab my red just so it stands out, skinny red. Let's draw in KQ as a radius. And then we're gonna do what we can to work with this little right triangle in here. So radius, we're gonna call it KQ, and we'll come back to finding it because there's so much going on with this problem. So, information given. QN to QP is 10. And this is where all of a sudden, you guys, I want to draw this circle over here because it's just so small. They tell me Q to N, here's K, here's Q. Q to N is 10. Got that out of the reading. They tell me that J to K, this whole thing is 4x. So I think this thing then is going to be 2x. And then the unknown radius is right here. Now, this is weird though, because I've got 2x sitting here and then I've got an unknown radius. So what the heck can we do with this? What do we know about these two segments, JK and ML, based on those last theorems? Just like it's theorem 10.9 right here. JK and ML are equal. We can go find x this way first. 4x is equal to 6x minus 24. Finding x first. How do we know? We got to work through this problem somehow, and when I stopped here, I needed to figure out what x was, and that made me go look back at the drawing and say, all right, this JK side and this ML side can be set equal to each other. If I take 6x's away from both sides, one of my favorite no's here, my favorite mistakes, don't lose your negative. Don't lose your negative. Divide by -2. X is 12. Now, that's great. X is 12. How's that going to help me get the radius? Well, this side was 2 times X. 2 times 12 is 24. There we go. Now I got something I can work with. 10 squared plus 24 squared equals R squared. It's going to be 100 plus 576 is R squared. Why don't you guys finish that up for me? I got to take my sweatshirt off. It's hot. Take the square root of 676, and that'll be our radius. Anybody get there? Yep. And does that make sense? The hypotenuse is 26. You got it. Holy cats. Is there going to be a problem similar to this on your test? Yes. I'm not going to put you in a situation where it's as complicated that you have to dig for it. Do you need to be able to identify these relationships? You do. I don't know if I need to see you do so many steps is all. You got your 12, but you didn't find the radius. And I remember that being an issue on that first quiz you guys took, that there was a question like that. So I think we should take some time to talk about that 10-1 to 10-3 quiz as well here in the next couple days. All right, let's go finish up the 10-4. Okay, inscribed angles, you guys, inscribed. This was a big thing. Like, are we talking inscribed or are we talking centrals? On 23 here, and I know I'm off my line paper now because this stuff can be here. And some of you guys need to get off your phones, too. Thanks. Anyhow. Inscribed angles. Yep. I'm doing it off my paper as you're all getting off your phones. I'm doing it on here. If I have the inscribed angle and I have to go out, I multiply. Double it. X is going to be equal to 80 for number 23. Let me go over here to 28. Similar. I'm outside and I got to go in. I'm going to divide by 2. Number 28, you should have got C is 56 divided by 2. That's 28. Right? Okay. Now, let's see. Other relationships. 24, if I remember right, this is the one where these angles across from each other, they're quadrilaterals here, they have to be supplements. They have to add to 180. So Q plus 80 has to be 180. That's easy. Q is 100. 4R plus 100 also has to be 180. Well, if I take 100 away, 4R's is going to be 80. If I divide by 4, your R there should be 20. That's number 24. Number 25. And I could go grab theorem names from this, but I'm going to leave you guys to do that. You don't have to name theorems on your test. 14D equals 70. When I divide both sides by 14, I don't know, what is that, 5? Perfect. D is 5 degrees. I'm already running out of room here. Oh, 26. This goes along with a theorem that says if you have the diameter of a triangle that goes through the center of a circle, then the triangle is right, and this corner is going to be 90 degrees. So the first thing I notice is I can put a 90-degree mark there. 3y equals 90. That's going to make y equal to 30. 3y is 90, so y can be 30 on that one. And then what I know about these other two angles, if that's a 90-degree angle, then 50 plus 4z is 90. That means 4z is 40, so z is 10. Two different things. That one was like kind of the most complicated, but at the same time it just applied one theorem, that P was a 90-degree angle. Now with number 27, inscribed angle V opens up to arc RS. So does inscribed angle T. It opens up to the same arc, RS. So if inscribed angle V is 39, then double it, I'd get out here, that arc is 78. Oh, well, divide by 2, guess what? N's also 39. I didn't even have to go out there and get that arc measure, really. I didn't even have to go get the arc measure. Now when I go to this other side, R opens up to VT, and so does S. So if these two inscribed angles open up to the same arc, then that means that they're the same measure, so M is also 44. Cool. Now, the rest of the problems, 29 to 38, I think we said. Ooh, no. Which one do I want you guys to skip over? Let's go looking together right now. Circles, circles, circles. We are going to not do any crazy Algebra 2 factoring for number 47. Not do any crazy Algebra 2 factoring for 47. So due on Thursday, tomorrow is the 10th, is going to be problems 29 to 46 and 48. Bless you.